Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, we will solve one question which was in sample paper issued for session 2022 and 23 from the topic electrostatic potential energy. The question is three charges minus Q, capital Q and minus Q are placed at equal distances on a straight line. If the potential energy of system of these charges is zero, then what is the ratio? Capital Q is to small q. Now this is the placement of charges. We take 3 points O, A, B. The distance of A from O is R and distance of B from A is R. So distance of B from O will be 2R. So we are placing all the three charges minus Q at O, capital Q at A and minus Q at B along a straight line. To calculate total potential energy of the system, we will take all the charges to zero, to infinity, not zero, to infinity. Then what will happen? We will bring one by one these charges and we will place them on points O, A and B respectively. So what we do? We first bring charge minus Q from infinity and place at point O. Because this charge has been brought at point O and there is no other charge initially present here, so it is being brought in zero field. So force acting on this charge will be zero when it is brought from infinity to be placed at point O. So work done will be zero. So work done in bringing minus Q charge, because there is no field, so it will be zero. Then bring charge capital Q and place at point A. This capital Q has been brought from infinity to be placed at point A in the presence of charge minus Q. So there will be force between these two charges. It is being brought in the field of minus Q charge. So force will be there and work done will be there. So we are bringing in the presence of minus Q charge, the charge Q. So work done will be 1 by 4 pi epsilon naught, already charge placed capital Q at point A, and because it is in the field of minus Q charge, which is placed at point O initially, so it will be minus Q divided by distance between two points R. Because we are calculating work, which is a scalar quantity, so we have to keep in mind the sign of charge also. We are not going to put only the magnitude. We are putting value of charge along with sign. Now, bring third charge minus Q and place at point B. It will be brought in the presence of minus Q already at point O, and work done will be there because already field of minus Q charge is there. Then bring this charge at point B. It is also being brought in the field of charge capital Q at A. So two works will be there. We will calculate both the works, 1 by 4 pi epsilon naught. First in the presence of minus Q at point O, minus Q into minus Q upon distance between B and O, it is 2R. Then it is placed in the field of capital Q placed at point A. So it will be 1 by 4 pi epsilon naught, charge brought at point B minus Q, charge already present at A, capital Q, and distance between A and B, R. So total work done will be 1 by 4 pi epsilon naught R. I can take common in from all the terms. It will be minus Q, capital Q, plus Q square. Minus Q into minus Q will be Q square divided by 2. Then minus Q, capital Q. This work will be stored in the potential energy. This will be the potential energy of the system. But in question, it is written potential energy of the system of the charges is 0. So U is 0. So I will put this value equal to 0. So it becomes minus 2qq plus q square by 2 equal to 0. This will go to other side. Now, here q is common. So minus 2q plus q by 2 is 0. So take q to the other side. So minus 2q plus q by 2 is 0. You can say minus 2 capital Q equal to minus q by 2. So this 2 will come here. It will be, negative sign will cancel because I have to calculate capital Q by Q. This Q I will take here. 2 will come in denominator on other side. So it will be 1 by 4. So answer of ratio of capital Q and small q will be 1 by 4. Thanks for watching this video. Like, share, subscribe my channel.